Hello boys and girls, welcome back to Jabulani's Playhouse. I'm Lani and I'm Jabu, and we're going to finish up our science experiments here today. We're going to do the fifth test tube and the last test tube, right? That's right, Jabu. It's been a lot of fun so far. We've had a ball, haven't we? We sure have. We've been mad scientists. Mwahahaha. That's right, Jabu. It's been super fun. Thanks for joining us with all these experiments, boys and girls. This is Test Tube Adventures from Lab in a Bag, and be amazing, right? Exactly. So let's see what's on store today in our last experiment test tube. Hey? Yes, please. All right, here we go. Ooh, garbled marbles, Lani. Ask yourself science questions as you sort these mixed up jelly jewels. Wow, that's cool, Jabu. I think they got some stuff inside, hey? Aha, they do. Those are garbled marbles in there. Let's take them out and have a look-see, hey? Alright, we'll just put the cap on, put it back for now. Okay, what do we have here, Lani? We have the fun stuff. There it is. Oh, look at these colors. Wow, these are neat, hey? These are super cool, Jabu. They're small little marbles, hey? Garbled marbles. These are cross-linked polyacrylamide polymer gel, so these are going to grow quite large, I think. So we've done some of that before, haven't we, with our disappearing jelly ice, right? That's right, Jabu. I remember now that you mention it. Okay, what's going on? Let's see what we do here. Garbled marbles. Ask yourself science questions as you sort these mixed up jelly jewels. After you become an expert in your field, watch them grow to giant jelly sizes. And then we've got warnings, of course. That's right. What you'll need from the test tube: garbled marbles, multicolored beads. You get it stuff. Your notebook and pencil, assistant with good eyesight, disposable cups or bowls, and water. One of the most important aspects of all science is classification and categorization. It's how scientists make discoveries and learn about the world. From mushrooms to sharks, microbes to molecules, stars to subatomic particles, scientists figure out science secrets by first studying and sorting. They ask questions such as, how are these things alike and how are they different? You can do just this as you embark on a study of garbled marbles. Ask yourself science questions and see if you can figure out the answers. Okay, let's try it. Carefully sort the garbled marbles. How many different colors are there? How many different sizes? Will the difference in the size and color of the garbled marbles affect how big they will become or how fast they will grow? Why do you think that? Write down your guesses in your notebook. Now do the experiment to see if you were right. Fill the disposable cups or bowls with water and put the different kinds of marbles into the different cups. Let them sit for a few hours. Check in on them from time to time. What did you find out? The science name for your garbled marbles is cross-linked polyacrylamide polymer gel. It's a big name, isn't it? Did you catch the word polymer in there? A polymer is really a big molecule made up of lots of little molecules linked together, just like a train is made of many train cars linked together. In fact, the word polymer actually comes from two Greek words, poly meaning many, and meros, which means units or parts. So a polymer is a big molecule made up of many parts. In polymer science, the train cars are called monomers, which comes from the Greek words mono, one or single, and meros again. And meros, which means units or parts, right? But why does it grow in water? Garbled marbles are like nets made of lots of little molecules connected together. Because they are like a net, water can sneak inside through the holes. That is, the crystals soak up water and keep it locked inside. The polymers that make up garbled marbles belong to a class of molecules called the superabsorbents. That means that garbled marbles are thirsty, very thirsty. Each marble can hold up to 300 times its weight in water. If you were a garbled marble, you would be able to drink almost 2,000 gallons of water. Jabu, that's a lot of water. It sure is. When the garbled marble crystals meet water, they start drinking. When they soak up the water, they expand, get larger, and soften. In other words, you added water to make big squishy marbles made of goo. Jabu, that's crazy. A pearl of a marble. These jelly marbles look like transparent, colorful jelly pearls. You might be surprised to know that real pearls come in different colors as well. Do you know where real pearls come from? Pearls are made by certain bivalve mollusks, like clams and oysters. When something that irritates the mollusk gets inside the shell, the mollusk puts a coating around the irritant to protect itself. It keeps adding layers and layers of coating, making larger and larger pearls. The coating is made of the same substance that the mollusks use to line the inside of its shell, a combination of calcium carbonate and a protein called conchiolin. Although people used to just look for pearls, now pearls are usually farmed. That means that people put something into a mollusk, like a little bead, and then wait for the mollusk to layer more and more calcium chloride and conchiolin over the bead until it becomes a pearl. People that farm pearls are called aquaculturists. Other things to try. Find a place where no one will mind a bunch of jelly pearls rolling around and play the slimiest game of marbles in town. After checking with your adult assistant, hold a jelly pearl several feet off the ground and then let it go. Hey, your garbled marbles bounce. Hee Jabu, that'll be fun to try. I know. I agree. Okay. How does it work? The secret of the bounce. If you could take a picture of your jelly marble at the moment it hit the ground, you would see that it looked pretty squashed. Your marble bounces because it is made of a polymer like rubber, which is very elastic. This means that it springs back into shape after it has been deformed, squashed, or stretched. Whether you throw the marble or just drop it, a lot of energy is contained in the motion, enough so that when it hits the ground, the impact can pull or push the molecules that make up the marble out of the places they want to be. But the molecules don't want to be like that. They will fight back. In fact, they fight back so hard in putting themselves back into the places that they want to be that they push off the ground, and the marble goes flying, boing, into the air. Scientists say that substances that do this have elasticity. Other substances don't have much elasticity. Have you ever played with clay? What would happen if you made a ball out of clay and dropped it on the ground? The same amount of energy would pull the ball of clay into a squash shape, but without elasticity, the molecules just get pulled or pushed out of their original places and then just stay there, flop on the ground. What other substances do you know that have elasticity? What substances do you know that don't? Physics fun. How high will the Super Bowl fly? How much of the energy from the motion of the jelly marble gets transferred back into the bounce energy by the elasticity of the molecules? You can try it and see. Hold the jelly marble close to a wall and drop it straight down. Measure how high the jelly marble bounces on its way back up. If the jelly marble reaches as high during the bounce as it was before you dropped it, then all of the energy in the motion of the marble was transferred back into bounce energy. If the marble acts like a clay and just sticks flop to the floor, then none of the energy of motion was transferred back into bounce energy. If the marble bounces half as high, then about half of the energy was transferred back. How much bounce energy is transferred back? None, some, half, most, or all. Try this test on different surfaces. What kind of surface will allow the marble to bounce higher? A hard one like cement or a soft one like carpet or grass? I think it'll be a hard one, Jabu. I think you're right, Lani. Having trouble bouncing back? What makes the marble stop bouncing? As you probably noticed, not all of the energy from the motion of the marble gets transferred into bounce energy. Where does it go? Where do you think it goes? Some of it gets transferred to the floor where the marble hit in the form of heat. The floor will actually be a little bit warmer when the marble hits, although probably not enough for you to notice unless you had a very sensitive machine to test it. Some of the energy gets transferred to the marble itself. That very sensitive machine could probably sense that the marble gets just a little bit warmer after every bounce too. Lastly, listen very carefully when the marble hits the ground. What do you hear? Some of the energy turns into sound energy. A talking bouncy ball. How cool is that? Hee hee, Jabu, that's lots of fun. I know. Okay, Lani, you can see we've got our little marbles there. Let's get a close-up. You can see we've got different colors, right? So we've got like dark blues, I guess, light blues, greens, clear ones. We've got 3 different colors of sort of red. We've got red and darker red and sort of an orange one. And then we've got some yellow ones too, right? That's right, Jabu. They look like a lot of fun. All right. And now we have our water, our bowl of water. We're just going to use the 1. So that'll be fun, right? With our garbled marbles. So let's see what we're going to do again. So we sorted them, as you can tell. And what do you think the size of the color of the marbles will affect how big they will become or how fast they will grow? I think the size will make them bigger, right? If the bigger ones will be bigger, right? I think you're right. So fill the disposable cups or bowls with water and put the different kinds of marbles into the different cups. Let them sit for a few hours, checking on them from time to time. What did you find out? Sounds fun, Jabu. I know. Okay, we'll plop them all in. We're just using the one bowl. So, plunk, 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 plunk. Jabu, they're not actually making that sound. Plunk, plunk, plunk. I know, I'm making that sound for them. It's fun. See, we don't want to put all of them in. We'll probably need a huge cup because these very thirsty, they said. They can go up to 300 times their size. I think that's what it said, didn't it? I think it said something like that, Jabu. Okay, is that all of them? Alright, there they are. Let's have a look at them. Wow, Jabu, they're small right now. We'll come back and see how much bigger they got in a little while, hey? We sure will. Okay, boys and girls, so it's the next day, and we now have all our little marbles. You can see them in there, and they all look pretty much the same size. Let's take a close-up. Lots of different colors, hey? They sure are, Jabu. They look terrific, hey? They do. They're similar sized, maybe a couple bigger ones, but roughly the same size. Let's take a close-up in our hands. Okay, so here they are. Nice little squishy marbles. Very squishy. Whoops. They bounce around a lot. Very bouncy. Let's see if they can bounce on. Here. So we're going to drop it from here. Hee Jabu, they bounce well. They do. They bounce really well, Jabu. I know. Let's try another one. Let's try a blue one here. Okay. They bounce really good, Jabu. I'm very happy with them. I know, me too. Wow, they worked out terrifically well, didn't they? They sure did, Jabu. Those are our little garbled marbles. And that's the end of our science experiments, isn't it? It sure is. Well, thanks for joining us, boys and girls. I hope you enjoyed that. That was a lot of fun, wasn't it, Jabu? It was terrific fun. We loved that, and hopefully we might do some more lavender bags if we can find some, because we enjoyed those science experiments. They were a lot of fun, weren't they? They sure were, Jabu. It's crazy how big those little marbles got, hey, considering that they were so small. I know they can absorb up to 300 times their weight in water, I think, so that was terrific. Well, thanks for joining us, boys and girls, and again, we'll see you soon, and until then, we miss you. Bye-bye for now. Bye-bye.